Hello friends, welcome back once again. This is Nagaraj SK, lecturer of Computer Science and Engineering Department. In this lecture with lecture number 48 and 49, I am going to continue with the last unit, that is greedy technique. So here I am going to brief you about Prim's algorithm, what is Prim's algorithm, how it works, and what are the applications of this Prim's algorithm. So, Prim's algorithm is used to find the minimum spanning tree. Prim's algorithm constructs a minimum spanning tree through a sequence of expanding subtrees. Following steps are followed to obtain minimum spanning tree using Prim's algorithm. Always select the edge with minimum weight. Then the algorithm proceeds by selecting minimum weighted edge adjacent to any vertex selected earlier. The selection of edge should not form a cycle. These are the steps which are followed by prims to obtain minimum spanning tree. So, if a graph is represented by its adjacency linked lists and the priority queue is implemented as a min heap, the running time of the algorithm is in big O of number of edges log number of vertices. This is because the algorithm performs number of vertices minus 1 deletions of the smallest element and makes number of vertices verifications, number of edges verifications, and changes of an element's priority in a min heap of size not greater than number of vertices. Each of these operations is a big O of log of number of vertices operations, then that is log n operations. Hence the running time is in n minus 1 plus e, then big O of log n, that is equal to e into log v, because in a connected graph number of vertices minus 1 less than or equal to number of edges. Then the pseudocode of Prim's algorithm. So Prim's algorithm says that Prim's algorithm for constructing a minimum spanning tree, it is used for constructing a minimum spanning tree. Just a minute. And the input is a connected weighted connected graph, that is g equal to v comma e. Then output is et, that is the set of edges composing a minimum spanning tree of given graph z. So Prim's algorithm construct a minimum spanning tree through a sequence of expanding subtrees. The initial subtree in such a sequence consists of a single vertex selected arbitrarily from the set V of graph's vertices. On each iteration, the algorithm expands the current tree in the greedy manner by simply attaching to it the nearest vertex not in that tree. By the nearest vertex, we mean a vertex not in the tree connected to a vertex in the tree by an edge of the smallest weight. Ties can be broken arbitrarily. The algorithm stops after all graph's vertices have been included in the tree being constructed. Since the algorithm expands a tree by exactly one vertex on each of its iterations, the total number of such iterations is n minus 1, where n is the number of vertices in the graph. That is, the tree generated by the algorithm is obtained as the set of edges used for the tree expansions. So here is the Prim's pseudocode of this algorithm, that is Vt is initialized to V0, that is the set of trees vertices can be initialized with any vertex. Then Et is initially equal to 0. Then for I equal to 1 to n minus 1, v minus 1 is nothing but n minus 1 vertices. Then do this, what we are doing, find a minimum weight edge, that is E star is equal to v star comma u star among all the edges u v comma u, such that v is in vt and u is in v minus vt. Vt is equal to Vt union of u star and Et is equal to Et union of E star, and then finally return Et, that is the set of edges composing a minimum spanning tree of given graph Z. Then construct the minimum spanning tree, that is MST, for the given graph using Prim's algorithm. So this is the given graph, so we have to identify here, this is the given graph, this one. Then we have to identify which is the minimum value, which is the minimum edge, which is the minimum which is the edge which is having less value, that is this one, this edge, it is having 10. So that we need to uh, this is the 10 less value, that edge we need to select this one. So this I have selected here. Then after that, from one there are two vertices we have here, that is 6 and 1. From 6 to 5 and 1 to 2, there are two edges connected to these two vertex. Among them, which is the smallest one? So here 1 to 2 is 28, 6 to 5 is 25. Then 25 is the smallest one, that we have to select. So I have selected here this one. Then, and the work of 6 is over now, and 1 is from 1 to 2 is there, right? 1 to 2 is there, and 5 to 4 is there, 5 to 7 is there, right? So among these three, which is the smallest one? 22 is there, 24 is there, 28 is there. So 22 is the smallest one, so that I have selected here. Then next we have, from that, from fourth vertex, again we have 12th as the least one, so that I have selected, this I have selected. Then after that, from 3 to 2, that is 16 is the last one, that we have selected. Again from edge vertex 2 to 7, there is a edge with the value 14, so that we have selected. So totally, finally, since all the vertices have been included in the minimum spanning tree, so we will be stopping it. Now the cost of minimum spanning tree is sum of all the weights, that is from 10, 25, 22, 12, 16 and 14. 10, 25, 22, 12, 16, 14. So it is totally 99 units. This is how the Prim's algorithm is used to solve or to find the minimum spanning tree of the given graph. And this is one more example, please go through this and solve this. If you are having any doubts in this, please do ask me, definitely I'll be helping you out. Then let me summarize what we discussed so far. So what is Prim's algorithm we saw, then the pseudocode of Prim's algorithm, and finding minimum spanning tree using Prim's algorithm, and finally examples. So this is all about this session about this Prim's algorithm. If you are having any doubts in this, please do ask your queries. Thanks for watching.